Hello everyone. Today we study about the machine cycle. So, machine cycle means the time taken by the process to perform a single operation is a machine cycle. Each machine cycle is divided into a T state. Second is the instruction cycle. The time taken by the process to complete one instruction, consisting of one or more than one machine cycle. Every instruction has two parts, opcode and operand. Now the timing diagram. The graphical representation of execution time taken by the process for the instruction represents specific instruction cycle in the term of machine cycle, and T state means collection of T state form the machine cycle and number of machine cycles form the instruction cycle. So there are three types of machine cycle: memory read and write, IO read and write, and request acknowledge. Next type of machine cycle is write machine cycle. In memory write operation, 8085 microprocessor places the address on the address bus, identifies the operation as a memory write. So for the write machine cycle, IOM bar is equal to 0, S1 is equal to 0, and S0 is equal to 1. Now how to draw write operation machine cycle? Again we want write operation 3T state. So draw first 3T states. Write all the signals is here. Clock signal A15 to A8, AD7 to AD0, ALE signal, IOM bar and write. Then draw the clock signal again as it is. Go for decrement, then the increment. In this way, draw first clock signal, then draw the column for the higher order addresses, then draw columns for the lower bit addresses and for the data. See the difference between all these T state. At A15 to A8, the address write in the column which start from the T1 to T3. Hold the column for the higher bit order. But in AD7 to AD0, we know AD7 to AD0 has the data in the multiplex, means address are the separated and data are the separated. For that only one T state we store the data, and next half of the T2 state to half of the T3 state we store for the data. So when AL is high, that time we store the address, and when AL goes to low, that time we store the data. For that our IOM bar is equal to 0, S0 is equal to 1, and S1 is equal to 0. And the write operation is goes when the data we write in the machine cycle. That time only our write bar goes to low, otherwise it is high. I hope you get the idea about the write machine cycle also. All these machine cycle we understand in the better way when we solve the instructions. But first we see the difference between the IOM bars signals, difference between the read, write and opcode fetch signals. First, IOM bar is equal to 0, S1 is equal to 1, and S0 is equal to 0. That time only read machine cycle. So first, opcode fetch machine cycle. The first step to execute any instruction is a opcode fetch cycle. In this cycle, the microprocessor bring in instructions opcode from memory. IOM bar is equal to 0, S0 and S1 are the 1. The machine cycles we required for the opcode fetch is 4 T states. So how we draw the opcode fetch machine cycle? We know for the opcode fetch we want 4 T state. So first draw the columns for the T state, means T1, T2, 3T and T4. Then write all the signals which we want to draw in the machine cycle, means clock signal A15 to A8 for the higher order memory addresses, AD0 to AD7 for the lower order memory addresses and the opcode means data. Then ALE, IOM bar, read and write operation. These signals we write here. Now first draw clock signal, means first goes to the increment, then at the lower side, then again we go from lower to higher side, means increment, and again draw a line, means this is our one clock signal. Repeat again for the next T state. Goes for increment, go first for decrement, then goes for the increment. Same way all the T state draw. Then second for our higher order memory addresses we write. For that purpose we draw T1 to T3, T1 to T4 one box where we write higher order memory address. Then next part for the unspecified. Then the next columns, next signals are AD0 to AD7. Now we know AD0 to AD7 are in multiplex, means when ALE is high, that time our addresses go, lower order addresses are go from address bus. Then when ALE goes to low, that time our address is go to the AD0 to AD7. Data is go for AD0 to AD7. So here opcode is go as our data. Then IOM bar, S1 and S0 signals. For the opcode fetch, IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 1. This is same for all the opcode fetch machine cycles. So store in our mind. Then when we opcode is read, that time our read bar goes to low, otherwise it is high. For read our opcode, our read signal is going to low. All these machine cycle we draw step by step at the time of the instructions we solve. Now the memory read machine cycle. Memory read machine cycle is exactly the same of the opcode fetch. It has only 3 T states. S1 signal is set to the 0, means in the read machine cycle IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 0. So for draw the read machine cycle, again first step is draw columns for the T state. So for the read machine cycle we want 3 T state. For that purpose we draw 3 columns first, then mention T1, T2, T3. At the left side we write all these signals, means clock signals, addresses, ALE, IOM bar signals, read bar, write bar, all these signals write at the left. So draw the clock signal same as the opcode fetch, means first go for the decrement, then go for the increment. Again next T state, again we draw the same way, first go for decrement, then go for to the increment. In the same way we draw clock cycle. Then we draw higher order memory addresses. Here we store higher bit addresses. Then here we mention lower bit addresses. Then data, this column is used for to the data store. So when our ALE is high, that time in AD0 to AD7 we store lower bit addresses, and when it goes to low, that time we store the data. So for the read machine cycle, our IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 0, and write bar perform high for the addresses, and when we read the data, that time it goes to the low and again it go for the high. We mention arrow also when we read the data. So in this way, draw the read machine cycle. Next type of machine cycle is write machine cycle. In memory write operation, 8085 microprocessor places the address on the address bus, identifies the operation as a memory write. So for the write machine cycle, IOM bar is equal to 0, S1 is equal to 0 and S0 is equal to 1. Now how to draw write operation machine cycle? Again we want write operation 3T state. So draw first 3T states. Write all the signals is here. Clock signal A15 to A8, AD7 to AD0, ALE signal, IOM bar and write. Then draw the clock signal again as it is. Go for decrement, then the increment. In this way, draw first clock signal, then draw the column for the higher order addresses, then draw columns for the lower bit addresses and for the data. See the difference between all these T state. At A15 to A8, the address write in the column which start from the T1 to T3. Hold the column for the higher bit order. But in AD7 to AD0, we know AD7 to AD0 has the data in the multiplex, means address are the separated and data are the separated. For that only one T state we store the data, and next half of the T2 state to half of the T3 state we store for the data. So when ALE is high, that time we store the address, and when ALE goes to low, that time we store the data. For that our IOM bar is equal to 0, S0 is equal to 1 and S1 is equal to 0. And the write operation is goes when the data we write in the machine cycle. That time only our write bar goes to low, otherwise it is high. I hope you get the idea about the write machine cycle also. All these machine cycle we understand in the better way when we solve the instructions. First we see the read, write and opcode fetch machine cycle. Which differences we see? First, IOM, when we perform read machine cycle, that time IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 0. Means take in your mind, when S0 is equal to 0 and S1 is equal to 1, that time we perform read operation. So when S0 is equal to 0 and S1 is equal to 1, that time we say the read machine cycle is execute. And when S1 is equal to 0 and S0 is equal to 1, that time write machine cycle we perform. And when both are the 1, means S1 is also 1 and S0 is also 1, that time opcode fetch machine cycle is execute. And IOM bar for whole 3 cycle are the 0. So I hope you get the idea how to take in your mind which signal is high and low for the read and write. Means S0 is equal to 0, that time read machine cycle is execute, and when opposite vice versa, S1 is equal to 0, that time write. Means one goes to low, that time another is goes to high. So S0 is equal to 0, that time read operation, and S1 is equal to 0, that time write operations, and both are the one, that time opcode fetch is performed. Now we start to solve the instructions. The instruction is add B, means A is equal to B plus A. Means the data of B add into the accumulator and store again into the accumulator. So we not communicate with the memory, not we read, not we write into the memory. For that purpose we only want one instruction, which is opcode. So this instruction is 1 byte and we want only a one machine cycle, which is opcode fetch. For that we assume the opcode for the instruction is 4fh, and for the opcode we want 4 TT state to draw the timing diagram. The given address we assume 1550. So when our AL is high, then first 15 least significant bit goes to the address bus A0 to A7, and then when ALE is low, that time the data is go, means opcode fetch is go to the data bus, and 50 most significant bit go to the A8 to A15. And at the time of opcode fetch, our status signals are IOM bar is equal to 0, S1 is equal to 1, S0 is equal to 1. And as we know, opcode fetch we want 4 T states. So first we draw 4 T state, T1, T2, T3 and T4, and here we write all the signals. So here we write all the signals. First signal is clock, then A15 to A8, A7 to A0, ALE, IOM bar S1 S0 and read bar. So how we draw? See carefully. First clock cycle we draw. Clock signal draw for all the machines are the same. So for in the direction of the decrement, then go to the increment and end to the first T state. Then again we repeat the same cycle. First we go to the decrement, then go for the increment. All the clock cycle draw the same way. So first we draw clock cycle, then we draw address bus. At the first T state we draw in this then at the fourth T state we continue with the line. So now our most significant address we draw, and here we write most significant bit of our address. So 50 is our most significant bit, so we write here most significant bit of the address. Now we know AD7 and AD0 are in the multiplex form, so for that we use ALE. So when our ALE is high, ALE draw high in the T1 state only, and then our ALE is good at the low. So in this way we draw ALE signal. Then when ALE is high, that time our least significant address goes to the AD0 to AD7. So we draw AD0 to AD7 is that like. and write our least significant address bit, which is 15. Now when our AL is high, then that time data is go to the AD0 to AD7. So for showing our data, we draw in between T2 and T3 data column, and joined with the dotted line. Write our data, means our opcode, which is 4A. Now draw IOM bar S1 S2 signal. For that, first draw in T1 state small column, then continue the square for whole the 3 is state. And mention our IOM bar is equal to 0, S1 is equal to 1, and S0 is equal to 1 for our opcode feature. So when our opcode is goes to the data, that time we read this opcode. For that, first our read bar is going to high, and when we opcode is read, that time our read bar goes to low, and again we go for the high. In this way we draw read bar signal, and we indicate arrow. So same in this way we draw all the opcode fetch machine cycles. Only difference is we only change the addresses and data, and other same process are the same for draw the opcode fetch machine cycle. So we know add B means add B's data into the accumulator and store again into a accumulator. So A plus B is equal to A. For this instruction we want only one machine cycle opcode fetch. In the same way, sub B INR B means subtract B. A minus B is equal to A, and INR means increment B. B plus 1 is equal to B. So for this type of instruction we want only one instruction, which is opcode fetch. So the next instruction is move C, M, means move the data of M means memory, move the data of memory to the register C. So data from the memory to register travel. So memory to register data goes to travel, means we read memory to register. So for this purpose we use two machine cycle. One is opcode fetch. First is opcode fetch and second is memory read, because we read the data from the memory to the register. Instead of this instruction, if we give the instruction is that like move M, C, means data of the register move to the memory. Data of the register go from register to memory. That time we perform write operation, means data of the register write into the memory. That time we perform write operation, and when we go from memory to register, that time we perform read operation. So now given instruction is move C, M, move memory's data into the registers. So memory to register we travels, that purpose we use memory read operation. So the given instruction is 1 byte and we use 2 machine cycle. One is opcode fetch and second is memory read. So for that we use 7 T state, 4 T state of opcode fetch and 3 T state of the memory read. So 7 T state we use. We assume 5A as our opcode. Then in opcode fetch cycle, IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 1. And memory read, IOM bar is equal to 0, S0 is equal to 1 and S1 is equal to 1. So we assume these addresses and the opcode fetch, and this is our data which we assume. Now we draw the machine cycle. For that we first draw 7 T states column, 1, 2, 3, 4 for the opcode fetch and next 3 for the memory read operation. And here we write all our signals which we perform in the diagram. As we know, the clock cycle for each machine cycle is same. So let's start to draw machine cycle, clock signal. So in this way we draw first clock cycle. Now we draw highest bit address data. We draw this signal for our opcode fetch and next we draw for the memory read. In this way we draw our highest bit address data. We write here highest bit of our address, which is first 20 and next is 30. They are our highest significant bit of the address. As we assume here 20, 15, 13, 23. So in this address 20 is our highest bit data and 15 is our lowest bit data. Same way 30 is our highest bit data and 23 is our lowest bit data. Now we draw AD7 to AD0 address and data bus. So in this way we draw AD7 to AD0 for the opcode fetch and next we draw AD7 to AD0 for the memory read machine cycle. Then here we write least significant address, which is 15, and the data means our opcode right here, which is 5A. Then again we write our small least significant address bit of the next address, which is 23 we mention, and the data is 50. Now we draw our ALE signal, which is high at the T1 state, and then for all the T state it is low. Now again for the second machine cycle is going to high and then it goes to low. So we completed ALE signal also. Now we draw IOM bar and S1, S2, S0 signals. Now we write here all the signals of IOM bar. M bar is equal to 0, S1 is equal to 1, S0 is equal to 1. And for read machine cycle, IOM bar is equal to 0, S1 is equal to 1, S0 is equal to 0. So in this cycle we read 2 times use read signal. First we read opcode, then we read our data. So how we draw read cycle, read signal? First our read signal is going to high. So first read bar going to high, then when we read the opcode, that time it goes to low, then again it become high. The next time in the read operation it again go to low and read our data, and again it goes to the high. That time we not write any data in our memory or the register. For that our write bar is become high for the whole machine cycle. Here now indicate the arrow for our read operations, and our timing diagram is ready. Now the next instruction is MVI B,06. The given instruction is 2 byte because with the instruction 8-bit data is present, which is 06. So that purpose the given instruction is 2 byte. If here no mention any 8-bit data, then that time it is 1 byte instruction. But in case of this move M, C, there is no any 8-bit data present, so the given instruction is 1 byte, and this is 2 byte because 8-bit data is present in the given instruction. Now this move M, C means move the data of C to the M, and the meaning of this MVI means move immediately 06 data to the B register. We transfer data memory to register, means we here perform read operation. For that purpose we use 2 machine cycle for this instruction. One is opcode fetch, which is compulsory to the all the machine cycle, and second one is read machine cycle, because we read 06 from the memory to the register B. Now we draw the machine cycle for the instruction. So the given instruction we know 2 byte, and we here assume address 4F is our opcode, and these two are the addresses. So for this instruction we use 2 opcode machine cycles. One is opcode fetch machine cycle and second one is memory read machine cycle. So 7 T state we required, 4 of the opcode fetch and 3 of memory read. So total 7 T state we use. Then we assume 4F is our opcode for the instruction, and we know opcode fetch has IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 1, and for the memory read IOM bar is equal to 0, S0 is equal to 0 and S1 is equal to 1. So first we draw all the 7 T states, T1, T2, T3 and T4 for the opcode fetch, and next 3 T state for the memory read. And here we mention all the signals which we draw in timing diagram. All the steps are the same as a previous instruction. First we draw clock signal, then address signals and ALE. So we now quickly draw all the machine cycle. I hope now you understand how to draw the machine cycle. Here we write highest address bit, which is our 20 and 30. So right here 20, and for the read it is 30. Now here we write least significant address bit, which is our 05 and 15. 05 and 15, and this is for our data, which is first is our opcode and second is 06. 4F 06. now as it is, when our least significant address is going, that time ALE goes to high and otherwise it is low. Now IOM bar for our opcode fetch is 0, S1 is equal to 0, S1 is equal to 0. This is same, means equal for all the opcode fetch. And IOM bar for the read is 0, S0 is equal to 0, S1 is equal to 1. Now again we here only perform the read operations, not perform the write operation. For that our write signal is high for whole the machine cycle. And here we first read the opcode. For that we indicate here arrow, and this is for our data. Now our machine cycle is ready. So now the instruction is move M, B, means we want registers data move to the memory, means we go from register to memory. So we know when we go from register to memory, we perform write operation. So for this instruction now we want two machine cycle. One is opcode fetch, first is opcode fetch and second is memory write. These two machine cycle we use for this instruction. Now we directly draw quickly the machine cycles. So as we know, this is 1 byte instruction. For that we use two machine cycles, opcode fetch and memory write. For that we use 7 state. So as it is, first draw 70 states, 4 for the opcode fetch and 3 for the memory write. Then draw the clock signal, highest bit address, then lowest bit addresses and the data. We assume 4F opcode for the instruction and 08 is our data. So first AL is high, that time we write here lowest bit addresses, then it goes to the low, again it goes to the high, that time we again write here second lowest bit address, then it goes to the low. So opcode fetch IOM bar is equal to 0, S1 is equal to 1, S0 is equal to 1. IOM bar for the write operation is equal to 0, S0 is equal to 1 and S1 is equal to 0. So first we read the opcode. For that read signal is first going to high, then low. When we read the opcode, then it again goes to high. And in write operation, write machine cycle, we not read any data, so it is hold the high for the. And next we write the data in the write operation. So in opcode fetch, the write signal is going to high, and then in write operation machine cycle it goes to low when we write the operation, and again it goes to high. Now we indicate here arrow for this is for read and this is for write operation. I hope no one have query how to draw machine cycles. Now the next instruction is MVI M,06, means we want copy 06 data into the memory. For that we know 06 is already present in the memory, then M is equal to HL, means memory stores 16-bit data in H and L register, pair of H and L register. So first 06 which is present in the memory goes to the register, then it store in register H and L register, then back to the copy into the memory. So first we read the data, then we write again into a memory. So write the data. So in this case we want 3 machine cycles. First is opcode fetch, then memory read operation, then memory write. So the given condition means instruction mvi m.06 is 2 byte instruction. For this instruction we want 3 machine cycle, opcode fetch, memory read and memory write, and we want total 10 T state, 4 for opcode fetch, 3 for memory read and 3 for memory write. We assume 4F is the opcode of our instruction. Then for opcode MV IOM bar is equal to 0, S1 is equal to 1, S0 is equal to 1. Memory read IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 0. Then for memory write IOM bar is equal to 0, S1 is equal to 0 and S0 is equal to 1. We follow all the same procedure for constructing the timing diagram. Means first draw all the T state, means 4 for opcode fetch, 3 for memory read and 3 for memory write. Then draw clock signal as it is for whole the machine cycle. Then draw highest bit address, then lowest bit address, data and address buses, then ALE. So in this way we draw whole the machine cycle. Now we write the data in the diagram. Means here we write higher bit address, which we assume 2022, 2023 and 2024. So highest bit addresses are 20, 20 and 20. So we write here our highest address bit for whole the machine cycle is 2020 and 20. Now we write lower bit addresses which are 22, 23 and 24. So for the opcode fetch 22, memory read 23 and memory write 24. Now the data is 04, 06 and 06. So 4F is our opcode, then 06 we read and then we write 06. Now ALE for high for every T state, first T state of the machine cycle. So we mention 3 T's for our high and remaining all are the low. Now IOM bar for the opcode fetch is 0 to 0, S1 is equal to 0, S0 is equal to 0. For the read IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 0. Now for the write IOM bar is equal to 0, S1 is equal to 0 and S0 is equal to 1. First we read the opcode, that purpose read signal is shown here. Then we read the data. So again we load the read signal, then hold the read signals are the high for the write machine cycle. Then write signal for the opcode fetch and the read machine cycle is high, and when we write the data, that time our read operation goes to low and read the data. I hope you understand how to draw machine cycle for this instruction. Now the instruction ADI means add immediately. ADI 05 means 05 plus A is equal to A, means our data 05 add into the accumulator and the result also store in the accumulator. So 05 is present into the memory, then it transferred to the register for the addition. So that time we perform read operation. When the data 05 transfer to the register for the addition, then we perform read operation, and result also store into the register, so no required to write the result into the memory. So this instruction we use only two machine cycle. First is opcode fetch and second is read, memory read machine cycle. How we perform ADI 05 instruction? In the same way we perform UBI, means subtract immediately. That time also we require only two machine cycle. One is opcode fetch and second is memory read. So the given instruction is 2 byte. For this instruction we use two machine cycle. One is opcode fetch and second is read. We assume 8A is our opcode. We want total 70 state, 4 of opcode fetch and 3 of read, memory read machine cycle. Then for the opcode fetch, again IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 1, and read machine cycle has IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 0. We assume addresses 5105 and 5106. As our first step, we draw all the columns, T states, 4 for the opcode fetch and 3 for the read. Then we draw clock cycle, then addresses, ALE, IOM bar. Now here we mention all these data, means higher bit addresses are 5151. So we write here 51 51. Now the lower bit data 05 and 06, 05 and 06, these two columns for the data. First here we mention the opcode, which we assume 8A, and data is our 05. Now IOM bar signal is 1 for the opcode fetch. S1 is equal to 1, S0 is equal to 1. Again for the read machine cycle, IOM bar is equal to 0, S1 is equal to 1 and S0 is equal to 0. So we not perform any write operation. For that whole the write signal is high and this read signal low, because we here read the opcode and here we read our data. Draw arrow also. Now our machine cycle is complete. Again the next instruction is LXI-R and the data, which is 16-bit data, means load register pair immediately. So for this R means register, any register, means example LXI-A, LXI-C and this 16-bit data. So these are the 3-byte instruction, because 16-bit data is present here. If here instead of the 16-bit, if the data is 8-bit, that time the instruction is 2-byte, and if no any 8-bit data present, means only the registers are present, that time this is 1-byte instruction. So now here 16-byte instruction present, so the given instruction is 3-byte. Now the meaning of this instruction, load register pair immediately. How we perform this instruction? First 20 bit are our higher, first 8 bit are our higher register bit. First 8 bit is our highest significant bit and second bit are our lowest significant bit. Means pair of register means D and C, H and L. That way the pair of the registers are performed to transfer this 16-bit data. So first 8-bit goes from memory to register, means first go 20, which is highest bit data, then next time go lowest bit data, which is 30. So in this way we transfer this 16-bit data to the register. So for this instruction we want 3 machine cycle. First is opcode fetch, second is memory read, and third one is also memory read. This memory read for first 8-bit data transfer and second memory read for second bit transfer. So totally 16-bit data we transfer from memory to register. The second instruction are also STA5060, means this 16-bit data, and the meaning of this instruction is store accumulator in a memory location. Means first our least significant bit goes from memory to register. So first read operation we perform to transfer higher bit address data, then we transfer next 8-bit data, which is 60, memory to register. Then what the meaning of this instruction? Store accumulator in a memory location, means this all data we store at the accumulator. Now we store this accumulator to the memory. For that we perform the write operation. First we transfer 8-bit data using read operation, then again next 8-bit data transfer with the help of second read operation, and then for write at the memory location we use write machine cycle. So total 4 machine cycle is required for this instruction. First is opcode fetch, second is memory read, third one is also memory read, and fourth one is write. One more instruction, LDA5162, means this 16-bit data, and the meaning of this instruction is load accumulator contain which available to the memory location, means we store the data in the accumulator from the memory to register. So first, as it is, we transfer first 8-bit data by using read operation. 51 first we transfer, then next 8-bit data we transfer with the help of the read operation. Memory to register is 62. Again we want to load accumulator, means the data which present in the memory we want to store at the register A. For that purpose again we use third read operation to load the A. So here total we use 4 machine cycle. First is opcode fetch, and remaining 3 are the memory read machine cycles. So total 4 machine cycle we use for this instruction. I am giving you these all machine cycle in the description box. Go and check and collect all the machine cycles from the description box. I hope you all understand the machine cycle, how to draw machine cycle. Thank you.